Hello, fourth grade mathematicians. Today's learning target is I can use a protractor to measure an angle in degrees and then determine if it is an acute angle, a right angle, or an obtuse angle. Let's start with a quick review from last week. Last week we learned what a point was. We learned that a point shows location and that it has a name. So the point shown here would be named point C. We learned what a line segment is. A line segment is part of a line. It ends on each side with a point. So this line segment ends on the left side with point A and on the right side with point B. And we call those endpoints. So we have two endpoints here, point A and point B. And because a line segment ends at a point on each side, we could measure it with a ruler. And without going into the exact measurement here, we can see that line segment AB is more than 2 inches, but less than 3 inches. And I want you to remember this right now. So we're measuring the length of this line segment with a ruler, but we measure other things with other tools. Like if I wanted to measure how much I weigh, I would go on a scale and see how many pounds I am. And later in this video, we're going to learn that to measure an angle, we use a tool called a protractor that looks like this. And that's how you spell protractor. A protractor is a tool that measures an angle in what we call degrees. Just like a ruler measures something straight in inches, or a scale measures how heavy you are in pounds, a protractor measures an angle in degrees. And we'll see how to do that a little bit later in the video. So back to line segment AB, which again, if we were going to measure it, we'd measure it with a ruler because it doesn't go on forever and ever in either way. It stops at point A, at the end point A on one end, and at the end point B on the other end. We would name line segment AB like that. We also learned what a ray is, and that a ray is different from a line segment because even though, just like a line segment, it has a point, an end point on one side, on the other side it keeps going forever and ever in that direction. And I want to stop here again and say that this ray that has that end point F, so it stops going, when we go this way it stops at point F, that's why we call it a end point. We can also call that a vertex. So point F can be called an endpoint, or it could be called a vertex. So let's look at this ray again. I see that it's starting at point F and ending at point F, but if we go in this direction, it goes forever and ever. And so try to remember from last time, would we call this ray GF or FG? And we would call this ray, we'd name it FG because it starts and ends at point F and keeps going through point G and then on forever and ever, and that's what that arrow tells us. We also learned what a line is. So we learned that a line is different from a line segment, because if this was a line segment, all you would see would be line segment LM with no arrows after that going left and going right. And if it were a ray, all we would see would be ray LM with that endpoint L, and then it would go through point M and go on forever and ever in one direction. But a line goes on forever and ever in both directions. So if we go this way, it goes on forever and ever, and that's what that arrow shows us. And if we go this way, it goes on forever and ever, and that's what that arrow shows us. And we call this line LM. That's its name. And finally, in the last lesson, we learned what an angle is. And we learned that an angle is made up of two rays that start at the same endpoint. And we can also call it the same vertex. So both of these rays, ray ST and ray SU, both share the same vertex. And we're going to use that word a lot today. So for this angle, point S is the vertex. And again, the angle is made up of two rays. One ray is ray ST, and the other ray is ray SU. And we learned that when naming an angle, and we didn't say it this way last time, but the vertex always has to be the second letter. So it either has to be called angle TSU, angle TSU, or it needs to be named angle UST, angle UST. And notice in both of those names, the vertex, point S, is in the middle. The vertex, point S, is in the middle. We could not call this angle TUS or UTS, because in those cases, we wouldn't have the vertex in the middle, and it needs to be in the middle when we name the angle. Next, I want to mention intersecting lines. And to intersect means to touch or cross over each other. And notice that these two lines do touch and cross over each other. Next, I want to talk about perpendicular lines. And perpendicular lines also intersect, meaning they touch each other or cross over each other. But they do it at a very specific angle. There's only one way that lines can be perpendicular. And I think that one of the best ways is to understand that is to look at something that's square. So here I have a square object. And notice I'm going to trace a line on this side and then on this side. And look how they look. So before I finish drawing the lines, so far I've only drawn line segments. I'm going to move this away so you can kind of see. And when I finish drawing those lines, the way they intersect, they're going to intersect so they're going to be perpendicular lines. And then I'm going to add some more information after I show that. So notice, even though they are intersecting lines, they intersect in a very specific way, and that's what makes them perpendicular lines. And notice that I used a part of a square object to trace those perpendicular lines, and just notice what the corner's like. Just notice how it goes. What we do is we call that a right angle or a 90-degree angle. And the way you'll see that drawn to tell you it's a right angle many times is with a little square. Just like I traced two sides of a square to create those perpendicular lines, we put a little square there to show that they're perpendicular. And when two perpendicular lines form an angle, well, we could also change this figure and make them two perpendicular rays. And that's what that would look like. And notice that there's that little part of that square left there to show us that it's a right angle. That's what we call it, a right angle. And so here we would say that ray CA and ray CB create or form a right angle, and the name of this angle is a right angle. That's how we say right angle. We'll also find out later that when we measure the angle, right angles are always 90-degree angles. And so again, that word perpendicular means when two line segments, two rays, as shown here, or two lines intersect at a right angle. When they do, they're perpendicular, in this case, perpendicular rays. And perpendicular rays form a right angle or a 90-degree angle. So when you use a protractor, you want to put the bottom of the protractor right in the middle on the vertex here, point F, and then run the bottom of the protractor along one of the rays. So notice that's how I have the protractor set up. It's on ray FE, starting at the vertex and the flat bottom part of the protractor running along the ray. And then we want to look at the inside scale, which starts at 0, and we go 0, 10, 20, 30 degrees all the way up to 90 degrees. And that's the amount of turn in the angle to get from the first ray that forms the angle to ray FG, the second ray that forms the angle. So this angle is 90 degrees, and like I said, right angles are 90 degrees. For right angles, we put that little part of the square down over in the bottom left, or where the angle is, to show that it's a right angle. So notice the square right by that part of the square right near the vertex. That tells us also that it's a right angle and that it's 90 degrees. So angle EFG is a right angle. Ray FE and ray FG are perpendicular to each other, and the measure of that angle is 90 degrees. So we already know what a right angle is. A right angle equals 90 degrees, and that little kind of sign there after the 90, that means degrees. So a right angle equals 90 degrees and looks like that. There's two more types of angles that I want to mention. One of them is an acute angle, and that's an angle that's less than 90 degrees, so less than, less than a right angle. And the other one's an obtuse angle, obtuse, and that's one that's greater than 90 degrees. One way that I remember that word acute, for acute angle, one that's less than 90 degrees, is it's a cute little angle. So those are less than 90 degrees. They're smaller than a right. They're less than a right angle. And obtuse is the opposite. It's greater than a right angle. It's greater than 90 degrees. So here's our right angle, which equals 90 degrees if we were to measure it with a protractor. And now I've added another ray, ray GA, and that creates two angles, right? It creates angle HGA or angle FGA. And it doesn't matter which of those two angles we're talking about. Each one's going to be acute because each one is less than 90 degrees. And we know that because angle HGF is 90 degrees. We can also measure it with a protractor. So let's measure angle HGA. So notice I took the protractor, I lined up that bottom kind of point where the bottom of that line with the vertex with point G. Then I lined up the bottom part with the ray GH. And now if we want to measure the angle HGA, we're going to start on the inside scale at 0 degrees, 10 degrees, 20 degrees. And it looks like it goes, this was an accident when I drew it, it goes right through 30 degrees. So it looks like this angle is pretty much exactly 30 degrees. And so since acute angles are less than 90 degrees and 30 degrees is less than 90 degrees, angle HGA is an acute angle. It's less than a right angle. It's less than 90 degrees. So now we know what an acute angle is, an angle that's less than 90 degrees. We know what a right angle is, a right angle that's exactly equal to 90 degrees. And remember, an obtuse angle is an angle that's greater than 90 degrees. So the first thing I want you to do is focus back in on our right angle here. So if we look at the black lines at ray GF and ray GH and the angle FGH, that's our right angle that equals 90 degrees. And now notice that I've drawn ray GB, and we're going to want to measure how many degrees angle BGH is. So go ahead and find angle BGH. And why don't you stop for a second and think, if we know that angle FGH is 90 degrees, and here you see angle BGH, is that going to be greater than 90 degrees, an obtuse angle? Is angle BGH going to equal 90 degrees? Is it going to be, which would be a right angle, or is it going to be less than 90 degrees, which would be an acute angle? So stop the video and make a prediction. Acute, right, or obtuse? Less than 90 degrees, equal to 90 degrees, or greater than 90 degrees? Okay, and we're going to figure that out by not just by looking at it at the moment, although eventually I think we can just look at them and sometimes tell. But we're going to use our tool, our protractor, to measure it. And let's remember how we use this tool, this protractor. We line that bottom part of the line of the protractor up with the vertex, the common vertex G, and then the straight part of the protractor along one of the rays that makes up our angle. So ray GH makes up part of our angle. And we're going to follow it all the way to ray GB to see how many degrees this angle is. So we're using the inside scale because we always start with 0. And notice we're going to go 0, 10, 20, 30, 40 degrees, 50 degrees, 60 degrees, 70 degrees, 80 degrees, 90 degrees, which is our right angle, and that makes sense because we already knew that angle FGH was a right angle. And we're going to keep going. From 90, we're not going to go back down to 80, we're counting up, right? So on the inside scale, 100 degrees, 110 degrees, 120 degrees. It looks like I'm just kind of getting lucky-ish today. It looks like that angle is 130 degrees, or maybe it's actually 131 degrees. Those other little lines are in ones. So I'm going to say it's 131 degrees. So angle BGH is 131 degrees. And notice I put the 131 degrees along that curved blue line because we're measuring the amount of turn from ray GH to ray GB. So 131 degrees, is that less than 90 degrees? No, so it's not an acute angle. Is 131 degrees equal to 90 degrees? No, so it's not a right angle. Is 131 degrees greater than 90 degrees? Yes, it is. So this is an obtuse angle, because obtuse angles are greater than 90 degrees. And one quick mention, since it's on IXL, if you have a straight line and you're asked for the angle, it's called a straight angle. If we measured it, it would be 180 degrees. Let me just show you on the protractor quickly. So notice I still lined my the middle of my protractor up on the vertex point B. We have ray BC and ray BA, and if we're going to measure from ray BC to ray BA, we're going to go all the way around the scale. So from 0 degrees, and I'm not going to follow it too much, to 180 degrees. And so a straight line, if they ask you the angle like that, is 180 degrees. It's called a straight angle. Okay, so here's practice problem number 1, meaning you're going to try it and then we're going to talk about it together. Take a look at this angle, and before we place the protractor on it, I want you to make a prediction. Is it acute, less than 90 degrees, a right angle equal to 90 degrees, or an obtuse angle greater than 90 degrees? So go ahead and make your prediction. So let's keep going. Notice that I placed the protractor on ray WY, and that we're going to be using the inside scale. So go ahead and measure the angle. So my first question is, how many degrees is the angle? And then my second question is it acute, right, or obtuse? So go ahead and pause the video and write how many degrees the angle is. If you have to rewind the video to look, then do it. And then write whether it's acute, right, or obtuse, and also maybe how you know. Okay, welcome back. So I started on the inside scale here because I lined up ray WY with the bottom of the protractor. And going on the inside scale, we go all the way from 0 degrees, 10 degrees, all the way to 100 and something degrees. And when I look past that line up there, it looks to me like it's 102 degrees. So if you said something like that, you're correct. And then you should have recognized that because it's 102 degrees, it's an obtuse angle. And the way I would write that is, this is an obtuse angle because it measures 102 degrees, and that's greater than 90 degrees. I also want to show you one more thing. We also could have put the protractor along ray WV. So notice the straight part of the protractor is along ray WV. And then notice that if we did that, we'd be starting on the outside scale. And that's the 0 on the outside scale. We'd go along the outside scale, 0, 10, 20, until we get to ray WY, which would still be 90, 100, 101, 102 degrees. So you could use the protractor either way, and that's how you use the outside scale. But either way, it's 102 degrees and it's obtuse. So before I show you practice problem number 2, I think we're just going to use this sentence frame. So this is a blank angle, and in the blank we'd put either acute, right, or obtuse. because it measures, we'd put the number of degrees that we figure out on the protractor, and then we'd say we'd either say it's less than 90 degrees, which would mean it was acute, that it's equal to 90 degrees, which means that it is a right angle, or it's greater than 90 degrees, which means that it's obtuse. Here's practice problem number 2. So first, take a look at the angle, and I want you to predict whether it's acute, less than 90 degrees, a right angle, equal to 90 degrees, or an obtuse angle, greater than 90 degrees. Go ahead and pause the video and predict. Okay, welcome back. I'm going to go ahead and set the protractor up. I want you to notice which ray I put the flat part of the protractor on, so you can figure out which scale to use to measure this. Okay, so notice that we are on that bottom ray, ray HI. I know you can't see the H. And just trust me that I set it up correctly, so that flat part of the protractor is on that bottom ray. Just ask yourself first, would you use the inside scale? Would you start at 180 and start counting down to measure this angle? Or would you use that outside scale and start at 0 and start counting up to measure that angle? And go ahead and give it a try. So we're measuring the amount of turn from ray HI to ray HG to figure out how much angle, how many degrees angle GHI is. So pause the video, and you want to write in, is this acute, right, or obtuse? How much it measures, how many degrees, and if that's less than, equal to, or greater than 90 degrees. Okay, so you should have realized this angle is about 14 degrees, and it doesn't have to be exact. So we'll say 14 degrees. That's what it looks like to me. And that makes it an acute angle because it's less than 90 degrees. And the way we would fill this in is like this. This is an acute angle because it measures 14 degrees, and that is less than 90 degrees. I forgot the word then. So now it says, and that is less than 90 degrees. So this is an acute angle. Here's practice problem number 3. I want you to take a look at this and predict whether you think it's acute, less than 90 degrees, whether it's a right angle equal to 90 degrees, or whether it's an obtuse angle greater than 90 degrees. So just pause the video and make your prediction. Okay, welcome back. I'm going to go ahead and place the protractor on it so you can figure this out yourself. Okay, so notice I put the bottom of the protractor on ray NM. We want to measure from ray NM to, it's actually ray NO. You can't see the O, but so how many degrees? Is it acute, right, or obtuse, and how do you know? Go ahead and pause the video. You can fill in this sentence frame. So I wrote that this is a right angle because it measures 90 degrees, and that's equal to 90 degrees. Now, someone may have thought it was 89 degrees, and if you did, then you might have written that it was an acute angle, or If you thought it was 91 degrees, you might have written that it was an obtuse angle, but I think most of you probably thought that it was 90 degrees and wrote that it's a right angle, like this. And since now I determined that it's a right angle, I'm going to put that little part square in there to show it that it's 90 degrees, that it's a right angle, and that rays NO and NM are perpendicular to one another. So now what you've all been waiting for, your exit ticket. Your exit ticket is going to be attached to the email, just like it has been for reading many times and just like it was for math last week. So you're not going to find it in the video. But either before you go to your exit ticket or after you go to your exit ticket, here are some things I would like you to check out. You can practice identifying acute, right, and obtuse angles in Z1 without a protractor, and also straight angles, remember the ones that are a straight line. You can use a protractor in Z4, and also right after Z4 there's one that doesn't actually have a number, it just has a letter like Z dot or Z star. It's called new, draw angles with a protractor. Z1 looks like this, so it says, is this angle acute, right, obtuse, or straight? To me, it looks like it's less than a right angle, so less than 90 degrees. So I'm going to choose that it's acute. I'm going to choose that this one's acute also. Ooh, I see a little symbol there. That tells me this one's equal to 90 degrees and it's a right angle. That one's a straight line. That's the straight angle that we're really not focusing on that much, but it's on IXL. 180 degrees. That one, I feel like the right angle would be somewhere like there, so it's greater than a right angle. It's obtuse. And then I'm going to let you go from there. That's IXL Z1. So IXL Z4 also asks you pretty much the same question. Acute, right, or obtuse doesn't have straight angles. And it has you using a protractor. Just notice on this protractor that you line the vertex up inside the little hole. That's what like a lot of like a lot of protractors look like. And so notice we have the bottom ray on the inside scale, and if it were a right angle it would go straight up to 90 degrees. So this is, sorry, that last one was acute. This one, notice we have the ray over here lined up on this scale, which is the inside scale, so we go all the way from 0 past, it's hard to see here, let's see, past 160 degrees, almost to 170 degrees. So is that acute, right, or obtuse? You should have said obtuse because it's a lot greater than 90 degrees. And there you go. And here we have a right angle. It's 90 degrees if you look on the protractor. This one might be a little bit interesting for some of you because it doesn't start at 0. Notice we could start at 90 degrees, go to 100, 110, 120, 130. So that's 40 degrees. It goes a little bit more than 40 degrees, which is less than 90 degrees, which makes it acute. So on IXL, on this one, on Z4, you might have to do a little bit of subtraction to figure it out. You're not necessarily going to start at 0 degrees to figure out whether it's acute, right, or obtuse. So since it's just a little bit above 40-something degrees, it's less than 90 degrees and it's acute. And also in Z4, they actually have you measuring your own angle. So notice here, we're starting on the inside scale, that bottom ray is lined up on the inside scale. So we're going to go 10, 20, 30, 40, 50, 60. I'm going to say 65 degrees is what it looks like to me. I think they may give you a little bit of room either way, but let's write in 65 and see if that works. Okay. And finally, on the IXL, that's right after Z4, but doesn't have its own Z number. It says draw angles with a protractor. It actually has you using the protractor to make your own angle, and it wants you to make an angle of 110 degrees. So notice here it starts at 0 degrees, and we want to get to 110 degrees. We're using that outside scale where the 0 is, and we will just keep going until it's at 110 degrees. So we'll keep going until we get it to 110 degrees. And it asked us to use the protractor to make a 110 degree angle. And here we did it. So I'll say it one last time. Your exit ticket will be attached to your to the email with this video lesson. But try IXL 4th grade Z1, Z4, and that other one where you get to actually draw your own angles with the protractor. And finally, I will be attaching to the email also the document where I actually cut out this protractor from in case you want to draw some of your own angles and measure them just to have some more fun, because geometry is fun. And I love using protractors to see how many degrees different angles are. So remember, our learning target for today was I can use a protractor to measure an angle in degrees and then determine if it is an acute angle, a right angle, or an obtuse angle.